John Huchra was born in 1948, about 14 billion years after the Big Bang. It's only during the last 100 of that 14 billion years that human beings have figured out that we live in an expanding universe. When John was born, no one really knew how fast the universe was expanding, how old it was, or where the galaxies were in that stretching space. Lucky for us, John Huchra saw our ignorance as a fantastic opportunity. As an astronomer, his principal goal was to learn the three-dimensional distribution of matter in the universe, much as we know and understand the surface of the Earth. If you measure a galaxy's redshift, you can infer its distance. This lets you add a third dimension to maps of the sky. On the Earth, adding altitude lets you understand mountains and canyons. Would a 3D map of the universe similarly reveal such grand structures? Soon after his arrival in Cambridge, Massachusetts in 1976, John joined Mark Davis, Dave Latham, and John Tonry in their quest to create what became the first CFA redshift survey, now known as CFA-1. The galaxies marked with small squares here were the observed targets of CFA-1. Right-click on any of these galaxies to learn more about it. The results from CFA-1, published in 1982, hinted that there might be interesting large-scale structure in the universe, but they were not conclusive. A larger survey with more redshifts was needed. After CFA-1, John entered into a tremendously fruitful collaboration with Margaret Geller, his colleague at the Center for Astrophysics. Margaret proposed that the CFA-2 redshift survey should employ a different strategy than CFA-1. She thought that more would be learned by sampling long, thin strips on the sky than by samples over a broader region, as had been done in CFA-1. The terrestrial analogy is that more can be learned about the Earth's general topography from a long, thin strip of elevation measurements stretching from coast to coast than from sampling elevations over a random patch of Earth. After all, the CFA mappers reasoned, a long strip would encounter rivers and mountain ranges and oceans, while a sampled patch could turn out to be all ocean or all Iowa. John, Margaret, and their students and co-workers began the CFA-2 redshift survey in 1984, using the long, thin strip strategy that Margaret had proposed. The first strip was 130 degrees long and just 6 degrees wide, and contained the 1,100 galaxies highlighted here. Seen on the sky, there's nothing particularly remarkable about the galaxy's distribution. You can clearly see the overdensity of galaxies associated with the Coma cluster, but that was not news. What offered John, Margaret, and their graduate student, Valérie de L'Apparent, a new insight was their 3D map. They looked at a view of their first slice, seen as if they could look at the universe from above. Here is the famous first slice from CFA-2, where velocity, a proxy for distance in a Hubble flow, increases radially outward. The range from east to west, stretching for 130 out of 360 degrees around on the sky, is shown as the angular coordinate from right to left. The thin range of 6 degrees north and south is scrunched down in this diagram, which shows galaxies of the slice projected to make a two-dimensional view, as if we viewed the universe from an orientation 90 degrees away from our usual sky view. It's easier to understand this diagram if we look at it in context, so let's put it there before we dissect its meaning. Shown here again are the galaxies in the first strip as projected on the sky in 2 dimensions. If we color-code the same first strip galaxies in a 3D view of the universe given to us by the modern Sloan Digital Sky Survey, we can see how a strip on the sky translates to a wedge in 3 dimensions. After the first strip, John and his colleagues went on measuring galaxy redshifts, strip by strip on the sky, until the total for CFA-2 reached about 18,000 in the 1990s. Here we show all 18,000 galaxies on the sky, color-coded by their redshift. Red markers are farthest, and blue nearest. The results from the CFA-2 redshift survey are best understood in 3 dimensions. Here we see the 3-dimensional locations of the same 18,000 galaxies we saw just a moment ago on the sky. The bubbles and sheets are now obvious, as is the Great Wall. The CFA Redshift Survey inspired many larger surveys. The Sloan Digital Sky Survey is shown here. The Sloan survey measured redshifts for hundreds of thousands of galaxies. The Cosmos synthetic 3D map of the Sloan galaxies, shown here in Worldwide Telescope, was created by placing two-dimensional images of galaxies at the right positions in three-dimensional space. The CFA survey, where each of the 18,000 galaxies is marked by a colored dot, was much smaller than the Sloan. But the essential features of large-scale structure, a network of filaments and sheets around voids, can be seen in the CFA survey alone. Nobody worked harder at its craft or enjoyed it more than John Huchra. He helped us all see more clearly the universe in which we live.